So, in a trip from Killinary to Cork, Charlotte and Shona drive 27 degrees west of south for 18 kilometers to Kinmar, then directly south for 17 kilometers to Glengriff, then 13 degrees north of east for 48 kilometers to Cork. What are the magnitude and direction of the displacement vector for the entire trip? So, the first thing I start out doing is we can call the four positions R1 for Killinary, R2 for Kinmare, R3 for Glengriff, and R4 for Cork. So the displacement for the whole trip is R4 minus R1. So in this problem, they give us the displacements for the three parts of the trip. And to make it easier to see, I use the A vector, B vector, and C vector for the three displacements. So the A vector is R2 minus R1, which is equal to 18 kilometers, 27 degrees west of south. The B vector is R3 minus vector R2, which equals 17 kilometers south. And then the C vector is R4 minus R3, which is equal to 48 kilometers, 13 north of east. Now the sum of these three displacements is the total displacement. So up here, I have drawn out a graph for which they did their journey. I used the conventional choice for the x-axis and y-axis, and I show that the first displacement in the A vector is directed 27 degrees west to south, and both the components are negative since west is in the negative x direction and south is in the negative x direction. Using this, I was able to obtain the equation here, which was that A in the x direction is equal to negative A sine of 27 degrees, and then I put my values in for this, and I got it that it's negative 8.17 kilometers, and then A in the y direction is going to be negative A cosine of 27 degrees, and all I did again was put my values in for that, and I got negative 16 kilometers. And then the displacement for the B vector has no components since its direction is south, so therefore Bx is equal to 0 and By is equal to negative 17 kilometers. So the direction of C vector is 13 degrees north of east. So both the components are positive. For this, I use the equation here, which is C sub x is equal to positive C times cosine of 13 degrees. And then I put my values in for that, and I get positive 46.8 kilometers. And then for CY, I get it's positive C times sine 13 degrees, which I plug my values in for that, and I get positive 10.8 kilometers. And now we can sum the x and y components separately to find the total displacement. So we use the equation change of x, ax plus bx plus cx. So I plug in my values, and I get 38.63 kilometers. And then I do the same thing for y. So the change in y equals ay plus by plus cy. And I plug my values in for that. And I got negative 22.2 kilometers for that. Now the magnitude and direction is the change in r. Are found using this equation right here, which is the change in r, which is equal to the square root of the change in x squared plus the change in y squared. Then I plug my values in for that, and I got 45 kilometers. So then to find the angle, you got to use the equation of theta is equal to the inverse of tangent. So then I got opposite over adjacent, which is equal to, I plug my values in for that, and then I get 30 degrees. So the magnitude of the entire trip is going to be 45 kilometers at 30 degrees.